Hi, everybody. I'm Kyle Miller. I'm the Director of Sales at Censys Technologies Corporation, and today we're going to be talking about a wide variety of things, but advanced operations and BVLOS and different technologies and regulatory strategies to get there.
Hi everyone, I'm Greg from Pilot Institute. We train drone pilots all over the country.
Hi, my name is Haye from DroneXL, where we cover all the drone news on our website.
Welcome to the latest episode of the PiXL Drone Show, our weekly podcast where we talk to industry professionals about what they do in the UAS space.
From professionals who use drone to fly inspection missions to public safety users or even drone light shows, you will learn on the PiXL Drone Show that drones are much more than just toys.
Welcome to another episode of the PiXL Drone Show, and today we are joined with Kyle Miller, who is the Director of Sales for Censys Technology. Kyle, welcome on board.
Yeah, thanks for having me, guys. I appreciate it.
So tell us a little bit more. We're going to be talking today about beyond visual line of sight, because that's really what you guys do. Tell us a little bit more about the company Censys themselves and maybe how it started and in very short where you are today.
Sure. So, Censys Technologies is, historically, we've always been an aircraft manufacturer. The aircraft over the years has certainly evolved, as has the whole industry. But I think as of the last couple of years, we are absolutely filling into our actual name, which is Censys Technologies and not Censys Aircraft. I think we're absolutely starting to bring more solutions to the table to round out the name of the company. Which is very, very exciting. But historically, aircraft manufacturer focused on vertical takeoff and landing fixed wing systems. The whole company is located right here in Florida, with remote workers kind of sparsed out and around. But all production and manufacturing activities occur right here. I'm sitting at our headquarters in Daytona Beach, Florida, with representation through channel partners all throughout the country. We do a little bit of international operations and customer stuff all around, a lot in Canada. But as we kind of expand the footprint and the success here in the United States, developing safety cases and getting CONOPS approved and associated with the aircraft, we'll expand that over time, as we're starting to see some of that now. But really the production and manufacturing and engineering of systems capable of over-the-horizon data collection.
Awesome. Yeah, I was just looking at the homepage of your company, and I see the drone on one hand, but then also SenseWise, data collection and analytics. So I guess when it comes down to it, a drone is just a way of collecting data. But before we go into the other stuff, can we dive into the drone, and can you tell us about the drone, all the specs, the features?
Sure. So I think one thing we've done really well over the years is integrating a wide variety of sensors and different types of payloads. Because to your point, the drone's really a way to get a sensor somewhere and to get a sensor somewhere effectively and efficiently. So, in my role and, being customer facing and hearing all of these different use cases associated with people flying drones around, they're flying a drone around to get a data packet, to get something presented to a client, to internal clients, whatever it might be. And if we had, a 24 megapixel camera and that was it, well, we're going to be catering to a pretty small section of operators. So over the years, through the universal payload integrations and housings and things like that, we've been able to expand the offering into LiDAR-based applications, thermal applications, live stream payloads, high megapixel cameras. Now even more recently up into magnetometry. So having a spirit of integration and a spirit of engineering right alongside the aviation piece, I think has been pretty critical to apply the technology and the BVLOS capability across the widest array of, users.
So the Sentaero is an eVTOL. You mentioned that, right? What kind of payloads can customers put on there? Probably everything and anything, right?
Anything under 4 pounds is pretty much fair game. And we have a physical volume that, can't be too crazy, but basically if it can fit, if the sensor can fit in a box, our Sentaero universal payload housing, and it's under 4 pounds and it doesn't consume, too much power. We have a lot of flexibility on the power side, but, size, weight, and power is the first question we ask when it comes to payload integration, and cost is the second thing. So, really it's swap C. what's the market for a $2 million sensor? It might be a little bit different than a $50,000 sensor, or an $80,000 LiDAR, or a $10,000 Sony camera, whatever it might be. But having that matrix starting at a fit check, size, weight, power is really where we always start. And again, physical volume, something like the Phase 1 IXM 100 or GS 120 is probably the biggest physical volume camera we have, without having to get incredibly creative on the fuselage side. So all those payloads integrating into the fuselage, we have a fixed fuselage that something has to fit into. So anything under 4 pounds that fits in that fuselage, we're going to take a good hard look at the market for.
And so the reason that you guys have a fixed wing drone, I mean, I imagine you are able to cover more ground more efficiently, have higher speeds if necessary. But then again, for some applications, let's say mapping, would it make sense to have a quadcopter style drone as well, where you can fly slower perhaps, or can you still do the same kind of missions with this drone as well?
Yeah, so I think the magnetometer is actually a really good example of the right tool for the right job. So looking at magnetometry in general, flying low and flying slow is preferred. Flying low is far more important though. And there's going to be areas with heavily vegetated environments or really steep and hilly terrain where flying 45 miles an hour is just not the safest option. Hugging the trees at 45 miles an hour with an expensive platform is probably sends chills down a lot of people's spines. But there's also plenty of areas that are a little bit more flat and open, where leveraging the efficiency of something like a fixed wing and getting the data you need without putting the aircraft in harm's way is also very valuable. So we're seeing that kind of matrix of fixed wing versus traditional quad or hexcopter for certain environments. That matrix is in play in magnetometry probably more than any other application. Being a vertical takeoff and landing platform, we can pretty much take off and land anywhere. We transition at whatever altitude you need to transition at in order to get above terrain. So we're not worried about climbing out of a vegetated area to get to cruise. There's a lot of flexibility in that VTOL functionality. Censys actually used to manufacture and sell a hand-launched version of our platform. That was pretty short-lived. The market wanted VTOL capability. And then the line-of-sight VTOL capability it's still offered today, but that was short-lived in its own right because the market wanted BVLOS capability. So we've been kind of evolving with the market with the focus on advanced UAS operations for quite some time.
Can you talk more about this magnetometer technology? What does that measure exactly? What's the application in real life for this?
Sure. So I'd say the reason that we started that integration and are getting towards the point of a sellable product is really for abandoned orphan wells is probably the number one at least domestic use case. Obviously, there's a fair amount of opportunity with mineral exploration, but really it's the identification and ultimate plugging of abandoned orphan wells. It's an environmental concern to have these things leaking into the atmosphere. So finding, digging up, and plugging abandoned oil and gas orphan wells is really the primary use case for at least why we went through that integration and who we see as the market for it in the short term.
I know there's thousands of orphan wells out there, but I guess they're not all identified and mapped. I mean, are there so many that are just out there and we are not quite sure where they are, and therefore we're using a drone to spot them, or?
Correct. Looking at like the state of Ohio, for example, there's about 50,000 in the state, give or take. Don't quote me on that number, but that's the number I've heard about from some of our customers doing work in that region with aerial magnetometry. Finding and plugging though, that's a tall drink of water to find 50,000. When a lot of them have unknown locations, and with all the federal money pouring in to do something about that environmental concern. It's become a big effort at the state level across many other states, not just Ohio. And magnetometry is just one thing. There's a lot of other states that are now resourced through the infrastructure bill to do things to repair America's infrastructure, to do something about our environment. And drones are one of those tools that are being looked at heavily to augment, the work that needs to be done by a certain year. Getting sensors places where it might be tough to get people or crewed aviation.
Wow. I had never really even thought that this was an issue anywhere. I guess probably not a big issue where I live, but very interesting, very interesting. Can you talk about the BVLOS thing? So you mentioned the customers wanted to do the BVLOS thing. We know in the United States it's been a bit of a holy grail, people call it, to be able to get the approval from the FAA. We're starting to see more and more of them because I think the FAA is starting to warm up to the idea of this. But you guys have been doing this for a while. What's the technological challenge to be able to accomplish beyond visual line of sight and I'm going to add and please the FAA at the same time?
Yeah, there's definitely technical challenges associated with it, but there's also a safety case challenge. So articulating the safety case with the technology you're using is a battle in and of its own right. And Censys is in the business of engineering, manufacturing, and selling BVLOS capable equipment. But with that being said, there's BVLOS capable equipment all over this industry. The challenge is articulating a safety case to the regulator to get permission to use that technology to its extent. An easy example is you can, in the right environment, you can operate an M300 further than line of sight and higher than 400 feet. And Censys has been at the forefront, along with a few other OEMs in this industry, that are really pushing the envelope for what is safe. And once we get to what is safe, how can we make it more efficient? Yeah. So go ahead.
No, I was going to ask you, like, what exactly did you guys do to make this drone safe and meet the FAA requirements? And can you tell us about the process and how long it took you to get there, basically?
Sure. So really, when we think about safety case design and subsequent aircraft design, we really have to do a series of questions and answers to answer two main questions. How do you detect and avoid uncooperative air traffic? And how do you mitigate the risk of overflight of people and property on the ground? So managing and balancing air risk and managing and balancing ground risk. Those are the two main components to a BVLOS safety case that have a lot of subsequent other things that need to be addressed. But how do you mitigate air risk? Well, how do you mitigate air risk for cooperative air traffic is different from how you mitigate air risk for uncooperative air traffic. So technological answers to that, at least in Censys's case, is an ADS-B receiver in detecting and subsequently avoiding cooperative air traffic, or in a 3-kilometer cylinder around the drone. As the drone's flying around, we're picking things up within 3 kilometers of it. But that's only an answer for cooperatives. There's still a fair amount of GA out there not transmitting ADS-B. So how do we detect and avoid uncooperative air traffic? That's really where the industry and Censys spends most of our time addressing. The ADS-B thing's easy. But what about the low-flying crop duster? All those types of scenario, the skydiving plane that's not transmitting. How do you detect and avoid those folks? Our answer to that, in part, is a forward-facing optical detect and avoid. So it's a camera on the front of the aircraft with computer vision tied into it that's got about 100 to 110 degree horizontal field of view and about a 1 mile range. So anything that's within our field of regard, whether it's a bird, a fixed wing, or a rotorcraft, is getting picked up via that computer vision, which is also tied into the autopilot, and an avoidance maneuver gets executed without pilot input. That avoidance maneuver, in terms of logic, is a descending left or right hand turn, or now a descent and continue straight for our linear applications. It's a very rapid descent, 100 feet down. And then if it gets another detection, another 100 feet down. That rapid descent, when people first see it, is very alarming is too strong of a word, but you get where I'm going with that. And then it levels off at whatever altitude you set in the flight plan for what those emergency procedures look like. And then ultimately, if 60 seconds elapses without another detection from that nose cone, then the drone goes back up and resumes its automated flight plan. The pilot can take it out of that autonomous behavior at any point in time. But the important thing is the pilot didn't have to put it into that avoidance maneuver. The computer vision's handling it because that optical sensor on the nose, it's not sleepy, it's not blinking, doesn't have red eyes from the night before. None of those things exist with that optical sensor in the nose of the aircraft. So we answer air risk mitigations through those two things, and then through, depending on the safety case or the concept of operations, additional mitigations could look like ground-based radar, maybe a visualization tool pulling radar data in from other sources, or in some cases, it's the good old visual observer, the human visual observer. There's a blend of technologies and humans in some cases that can satisfy air risk.
Is the drone just as capable of detecting moving objects in the air as well as static objects that are, let's say, or that are just based on the ground, like antennas, buildings, changes in elevation, those kind of things?
Yeah, it's a very good question. So we get that question a lot. It is a detect and avoid of flying objects. It is not an obstacle detect and avoid. That onus is still on the operator to flight plan accordingly. Look at sectionals when you're doing your complex flight planning. There's a lot of automated tools now that, frankly, we didn't even have when we were doing these flights in 2021, 2022 that we wish we would have had. There's a lot of companies out there that are doing quite a bit when it comes to source maps for altitude-based hazards, cell towers that weren't, that are up now that weren't up before. There's a lot of those tools that really automate the site survey process. The area analysis review is what we call it, prior to going out and performing a flight operation. You look at some of these BVLOS operating entities, whether they're our customers or not, they're spending several hours flight planning for 1 hour of flight time, and that's a mandatory process right now. And it's one that mitigates risk appropriately. And there's a reason that companies have, tens of thousands of hours operating successfully in a BVLOS capacity. It's because they're spending that time mitigating risk. But there's also some things that can be automated in that risk mitigation process. And that's what we're really, really excited about, is some of those automation tools where I can plug a KML into my flight planner, load it into my tool, and it tells me where my risks are. That's not a silver bullet. There's still going to be a need for well-trained, competent operators, whether they're in the field or operating remotely from an office somewhere. There's still going to be a need for competency in this industry, even with high automation levels. But there's a lot of those automated products that are coming online that are very exciting.
Yeah, I mean, this sounds a lot like ForeFlight. This is what I do when I go fly a real airplane, right? You go in ForeFlight, you do your pre-flight, you do all your research, you spend several hours doing that, even for a short flight, just because that's part of the pre-flight. So I'm glad you hear that. I'm actually surprised you said the evasive maneuver is a left turn. Generally, in aviation, when you want to avoid another traffic coming right at you, it's a right turn. Do you know why they pick a left turn?
Well, so the drone's not going to dynamically decide if it should go left or right. It's going to do whatever you set in the flight plan. So if you're flying a 50-mile mission with a mountain on your right, that's why you have the option to, if you're doing a rail application or something and you have obstacles on your right, you have the option to set prior to the flight which way you want to dive. And then it'll resume its auto flight plan. But that's that level of flexibility. I think the descend and continue straight is oftentimes going to be selected because it keeps you along your center line. It keeps you along your flight path. So that descend and continue straight wasn't always a feature, but the fact that it is now is giving our linear asset owner customers quite a bit of flexibility in somewhat limited right-of-way environments. We have rail customers that operate in pretty densely populated areas, but the right-of-way that they're overflying is not densely populated. So they're able to get a safety case approved where they can fly that rail, where they might have subdivisions on both sides, but they're able to say, we're not going to fly over the subdivision, even in an emergency procedure, because we can descend and continue straight. Or descend and hold is another option. Being a vertical takeoff platform, worst case scenario, we can always put it back into vertical flight and land the aircraft at a safe point.
That's cool.
So
the follow-up question I have is, you talked about ground-based systems. That seems expensive, and it would need to be installed over certain areas where there's going to be BVLOS. Is that correct?
That's an option. So you might have fixed infrastructure that could be well benefited from panel-based radars or We look at a wide variety of solutions. Again, we are not a radar maker. We're not an optical detect and avoid maker. We're an integrator of different pieces that fit an overall solution. So, we have customers using panel-based radars. We have customers using Casia G, which is the ground-based version of our optical system. It's a bunch of cameras on a somewhat of a mast in a 360-degree configuration, giving you airspace awareness out, a couple of miles. One solution that we like a lot that we've integrated with and sold is, we use it for our own operations. We did the whole last year's Sentaero tour with one on the top of our trailer. Is a 360-degree ground-based radar. It gives us, now with some advancements on their end, they're seeing 172s out to 12 miles. Wow. And that's a kind of a repurposed marine radar in a lot of ways, with a lot of other kind of fancy stuff going on the back end and the software side. But seeing, getting a 10-mile radius with a off-the-shelf solution like that, with all their own proprietary stuff going on in the background, I think that's a really high capability per dollar ratio when you're talking about radar. I've seen some panel-based solutions that might get you 5 or 6 miles worth of detection, but you need 4 or 5 panels to get 360. And now you're talking about a $400,000 or $500,000 radar set, which is, now you're starting to get priced out with the drone solution. So we've looked at a lot of different solutions. The radar we like is, a fraction of what I just described from a price perspective. It's a tool that we really like. Again, we're a customer of that as well as a user and reseller, because it's enabled quite a bit of flexibility for our own, proof of concept projects and things like that. So, we're going out and putting this technology to the test right alongside our customers, because a traditional Censys demo these days is not really taking off, flying around a parking lot and landing. That's not good enough for our customers anymore. We're going out and spending a week on site with customers, flying 50 to 200 miles, and giving them quality reports on the data sets, as well as how long it took us to do that. They want to know how it worked. And most of the times they're on site with us for the whole week or two. That's what a Censys demo looks like these days, which I think is really exciting.
Yeah, sounds way more involved than you might expect, right?
Yeah.
In terms of avoiding other aircraft, I know there's some other drone companies out there that used acoustic signals to spot aircraft and helicopters. Is that something you guys have considered? And if so, why the choice to go for a camera rather than using acoustic signals?
It's another really good question. So we actually did heavily consider acoustic-based solutions before we went the optical route. There's something to be said for optics with traditional manned aviation see and avoid requirements. There's a lot of language similar to that, whether it's a human seeing or a camera seeing. There's a lot of analogies and parallels that can be drawn that we kind of made a bet on that optics would be favored. And this was also in 2019, 2020, where the state of the acoustic detect and avoids, there's really only one company doing it well that we've seen. But the state of the amount of data that they needed to accrue to drown out your noise in all these different environments, capture and account for noise of a wide variety of other flying things in different ambient environments. It's come such a long way that I think Censys would be ecstatic to revisit acoustics as a detect and avoid solution, whether it's onboard or ground-based. We like onboard detect and avoid. We think it scales. We think, when it travels with the aircraft, it's our flying safe bubble as we're going everywhere. Ground-based solutions, to Greg's point, sometimes need to be networked, and that comes at a high price. So acoustics is something we looked at very heavily a while ago. And with how much things have changed in this industry, I think it's high time we look at it again.
Yeah, I believe when we had that conversation, I believe they said that the benefits were that you have basically the ability to pick up signals, of course, in any direction. And also, I think the fact that the range was greater than perhaps with camera, and the equipment may be smaller and lighter and less power hungry, I guess. So in terms of mounting it on an aircraft, there's some benefits there, it seems. In terms of So we spoke about mitigating air risk. We touched a little bit about ground risk as well. If the aircraft fails entirely, do you guys have a parachute on board, or is there a different way of mitigating that risk?
Another very good question. So we currently don't have a parachute integrated onto the Sentaero. Although we have customers operating over roadways and people and moving vehicles with approvals to do so, not just going rogue, but with approvals to do so without the use of visual observers because of well-crafted safety cases. We're looking at things like population densities and traffic volumes and injecting that into the safety case. Ground risk is one of my favorite things to talk about because it is operationally so beneficial to be able to cross roads. Even when we're talking about transmission line infrastructure, where it's out in the middle of nowhere and long stretches of nothing. And well, guess what? It might still cross a road. And if you can't legally cross that road, you're landing at the end of the road or at the start of the road, taking off again on the other side, repositioning. That whole thing might have taken an hour. Not usually, but let's say it took an hour, that you're losing that all because you couldn't cross a road for 0.7 seconds. If it's a 2-lane highway, we might be directly over that road for 0.7 seconds, which ultimately didn't matter anyway, because a complete failure, if we're directly over the road as a fixed wing, we're crashing somewhere way over here. The failure point that you need to be worried about is over here. And how do you measure that? So, there's a lot of operational flexibility and scale associated with unlocking ground risk and approvals for over people and moving vehicles of a platform in our weight class. We're a 23-pound aircraft with payload and battery and that kind of thing. That's not, that's more than what can be approved now under rule, but we're never going to comply with Category 3. And to my knowledge, this will change soon. There's a lot of really good parachute developers out there. There's no parachute manufacturer that's ASTM certified a parachute for a system in our weight class. We expect that to change, and that will change the minute a company like Censys goes to one of these parachute developers and says, here's $100,000, make it happen. That's when you'll start to see some of these things happen. But we're getting a lot of flexibility approved for customers just by articulating a lack of risk operating over certain roadways, certain people, certain sites, but all that to say that these approvals are performance-based still. We've had a few ops over people and moving vehicles approvals for site-specific areas. We had a Department of Transportation get approved for a series of roadways in Ohio. But we want to take that language and apply it to a performance-based approach so that customers can operate over any roadways, any amount of moving vehicles under certain limits in certain population densities.
Definitely want to talk about Ohio as well. It's funny. I think it was last week we wrote an article on DroneXL talking about how Wing, Google's company, actually decided not to use parachutes as well. They said that parachutes were not just heavy, but also hard to control in terms of where the aircraft would land. And then even if it does land, if there's a lot of wind, it might get dragged over the ground. So they had all these other risk factors basically that made them decide against using parachutes.
Well, there's the economic drawbacks of a parachute. If we put a 1-pound parachute pod on the aircraft, that's 1 less pound of payload we can carry. For us, that might reduce some of our sensor options. For Wing, it means they can deliver less percentage of parcels. They can't get an extra 2 envelopes squeezed into that, whatever it might be. That's the economic drawback to parachute. But there's also the safety drawbacks to parachutes, which you just described. We have some academic customers that operate, DoD systems that are parachute landed, and every once in a while, those things are getting cut out of trees. The drone's in the trees because the parachute landed a routine landing, but it drifted over into a place that it shouldn't have landed. And there's mitigations for that, I'm sure too, but we've never been parachute landed, so we've never had to worry about those mitigations and drifting into trees.
So what's the limitation right now as far as technology? Going forward, you can fly 200 miles an hour. Is it because is the battery the limitation? Is the link between the controller and the aircraft the limitation? What's the next stage to improve?
So from a technological limitation perspective, you're right. There are still some limitations to BVLOS operations. There probably always will be. Battery for us is one limitation, and for a quick point of clarity, we have about 50 miles of linear range. So assuming you can do a handful of flights a day, that's how you get that 50 to 200 miles worth of inspection done per day or linear operations done per day. We operate off of a multi C2 package. In that command and control package, we have a traditional direct radio link, whether it's 2.4 operating on 1 watt or up to 10 FCC licenses included and that kind of thing. But we also have a cellular-based command and control, which we're operating off of one of 4 carriers at any given point in time. So Censys leverages the L-Site Halo for that LTE solution, and we're going to fly around off of Verizon or AT&T or T-Mobile or US Cellular. The drone's going to dynamically prioritize which carrier is strongest at that point in time, and it'll operate off of that. So the integration of cellular was really a big step forward for us to unlock those really great radiuses from the GCS. Operating when we take off and landing 50 miles that way, that's very easily done in an area with coverage over the cell network. Eventually but there's still, I think 16% of the United States by landmass doesn't have cell coverage. There's still operations happening in those places. We have customers in the desert of Arizona and New Mexico right now that are experiencing spotty cell coverage. That's why we still have the direct radio link, so that operations aren't grounded for that purpose. But areas where there's no cell coverage is still a limiting factor. So that starts to talk about SATCOM. Low latency SATCOM being a solution for BVLOS over mountains in austere environments, international environments. That's one technological limitation right now is we still are operating off of radio, and even though cell's unlocked quite a bit, there's still limiting factors to cellular-based command and control. That's one thing I'd probably point to, and alongside battery, of course. I wish we could fly for infinity hours, because if we could, we would be able to do quite a bit of miles per day.
Mm-hmm.
Yeah, I hear you. Batteries is the bottleneck for sure, it seems. Earlier this year, you guys announced that you were working with the DOT in Ohio. Can you tell us a little bit about that project and what you guys are doing there and what was involved in terms of getting the approval to fly beyond visual line of sight there?
Sure. So I think Ohio DOT is one of those really forward-leaning states, for sure. The state of Ohio is really forward-leaning in aviation for obvious historical reasons. But as a DOT, I think they've really leaned into technology, specifically UAS. And really what started it with them a while back was they took a really crawl, walk, run approach to enabling BVLOS for the state. They also have the benefit of Sky Vision, that big 200 square mile Air Force sponsored sandbox where they're networking radars together, and you can access different parts of Sky Vision and tap into that radar network for air risk mitigations. And there's a certification process that you go through as a manufacturer and an operator to get whatever you're flying certified to kind of cover the ground risk component. And then they're providing you that sandbox for airspace awareness. So there's a lot of resources at the state leadership level that are enabling complex UAS operations in Ohio, and Ohio DOT is at the forefront of that. But starting from a crawl, walk, run approach of site-specific BVLOS areas, now talking about now they have performance-based approvals to do BVLOS operations. Now going into site-specific ops over people and moving vehicles approvals, ultimately expanding that into performance-based approvals as well. So it's really been an iterative process with Ohio, both as a state and as a kind of a direct customer of ours. They're incredible people. They have a really strong team, really strong leadership team at Ohio DOT as well. And then they're being supported at the state level so well through resources like Sky Vision and Drive Ohio and Fly Ohio and all these different Ohio's. And then I think one thing that's important to talk about as well, specifically with Ohio, but we see it in a lot of other states, is the infrastructure surrounding workforce development in these states. So you have 2 big schools in Ohio that are doing fantastic workforce development in Ohio State and Kent State. And then those programs are being supported and fed talent and programs and certifications through the 2-year colleges in the state, like Columbus State, and I think Sinclair's out there doing great work. There's a lot of UAS activity in Ohio. We love talking about Ohio.
Awesome state. So when you guys fly over the highway, what is it that you monitor and look for? Is it like monitoring the traffic or infrastructure or road conditions? Like what is it that you guys are looking for basically?
So I think ODOT's primary use case for our platform in Ohio over those roadways is traffic monitoring. Just knowing the payloads that they use on the Sentaero and the Sentaero 5. It's largely traffic volume and traffic monitoring. And then we have other DOTs that are doing things around roadways like construction progress monitoring and all the way down into pavement inspection. Do they need to restripe? How are the conditions of the roads on the side of the roads in these austere places? Are they cracking? Those are the types of things that we're seeing very common use cases with some of these DOT customers.
Yeah. Quick follow-up, actually. Who's flying the drone? Is it the people from the Ohio states doing the operations, or are you guys involved in operating the drone?
Yeah, so it's Ohio DOT's internal UAS program. We have seen quite a big swing towards the growth of internal programs at these state level organizations, whether it's a Department of Natural Resources, a Department of Transportation, a Department of Water Resources, the major electric utilities. All of these entities are growing their internal programs alongside their contractors. They are still certainly getting contracted services provided to them, but they are growing their internal capabilities as well, which is a lot of who we spend our time with, is these big internal programs and kind of setting an umbrella and a foundation of which their teams operate and their vendors operate.
So I have a question relating to the general public. The FAA is expected to have an NPRM for BVLOS flights coming out in the next couple months. I know a lot of people are getting excited, but I've been cautiously optimistic, trying to explain to people that what you guys do, for example, requires a lot of additional equipment, for example, on board of the aircraft, detect and avoid. A lot of people, and in passing, don't really understand detect and avoid and what is really required. And I think you explained it really well. What do you think this looks like from a general public perspective to be able to fly beyond visual line of sight? I know the FAA has talked about having two different types of BVLOS, a shorter BVLOS, few miles, versus an extended BVLOS. What are your thoughts on this? Do you see the general public in a year or 2 years being able to do this with what? Additional equipment? What's your take on this?
So I think it'll look a lot like Canada. What Canada's kind of announced for low risk BVLOS operations, 400 feet or less, 4 miles away from the operator or less, sparsely populated areas, all that can be done under Part 108. I think Part 108 is going to be the definition of rising tides lifts all ships. That is going to be a good thing for Censys Technologies when rulemaking enables short-range BVLOS with multi-rotor type platforms, where you don't need to go 50 miles away. You need to be able to check the next 12 towers, and the furthest you might ever get away from you is 2.5 to 3.5 miles or 4 miles. That's going to be a terrific thing for us. However, customers of the Sentaero 5 or subsequent platforms put out by us are still going to need to, in the short term, file for and get approval for waivers and exemptions and things like that. There's still going to be a need to operate beyond the scope of what Part 108 permits under rulemaking. I think we can take a really easy page out of Canada's book and look at what Transport Canada's approved for BVLOS rulemaking. I think that's what a lot of Part 108 is going to look like. I'm very optimistic that we'll be on schedule for that, 20 months, 4 months to get to an NPRM and then 16 months of that before final rulemaking. I'm very optimistic that we'll be on schedule. I think a lot of people are overly optimistic for what Part 108 will allow for. But the good news is that there's a lot of OEMs like Skydio and Percepto and Censys that are standardizing what can be done under waiver without risk of denial and a strong safety case behind it. I can't tell you the last time that Censys got a straight up denial when we submit a BVLOS waiver for a customer of ours. We might need to provide a little bit more information and dial back the ask, but we really don't get a denial. We just kind of need to shape the safety case to make it more clear or refine the requests we're making. So even if Part 108 is not the silver bullet for Sentaero 5 customers or, over the horizon type of desires, there's a very strong track record of those operations occurring today and over the weekend, which I can attest to with some of the calls we were working on with our customers over the weekend, where people are doing this stuff today. And if Part 108 doesn't get you there, there's a path beyond it, as there has been under Part 107. But I really do think Part 108 is going to allow a lot of people that wish they could have done X, Y, and Z over the last several years to be able to do it just as safely as Part 107 waivers.
So if you look at the drone industry and the rules and regulations that we have in place, let's say over the last 10 years, we started out with having basically no rules, if you will. Then we had rules that are actually quite strict. The last year, 2 years, it seems that the FAA is loosened up a little bit, realizing that drones are in fact still the safest aircraft around, and that all the fear perhaps was a little unfounded. If you were in charge of the FAA, like, what would you focus on and what would you do for the next 5 to 10 years to enable the drone industry to actually take off and grow and then realize all the things that people have imagined?
So selfishly, I would want them to hire more people for the waiver review team. So right now there's maybe, again, don't quote me on this number, but maybe less than 10 people that review these requests in Flight Standards waiver review team for BVLOS waiver requests. There's less than 10 people. So when we submit an application on behalf of a customer and the queue is long, having a 90-day feedback loop or approval process, that's a limiting factor. When it's the customer or whether it's us pushing the envelope with a novel request, to not know for 90 days and to have to make changes to that, maybe answer an RFI, that feedback loop stifles innovation when it's that long. There's some flexibilities with, you can take a prior precedent, build up a little bit from certain parts of the language and resubmit it, and you have a pretty good feeling, but you might not have your formal approval for 6 to 12 weeks. And it taking 90 days to get to a milestone, that's purely a function of manpower at the agency. And if I was, the director tomorrow, the first thing I would do selfishly is hire more people so that they can divide and conquer better than they've been able to, because I think they are doing great work once they get to it. The problem is the volume of work is so high and the requests can in some cases be so complex that they require man hours to review and approve if safe enough. And having more people would definitely speed up innovation, the American drone industry, feedback cycles and product implementations and, use case development and, get more people at least aware and educated on what the technology can and can't do. I think what the technology can't do is just as important in a lot of cases.
Yeah, it's a good point that you bring up, because if you look at lens approvals, they worked with third-party suppliers to speed up that process and make it near real time. So if the government isn't quite set up to, let's say, have a 90-minute turnaround, or at least faster than 90 days, maybe there's an opportunity for another party to step in and kind of provide those services at some point.
Yeah. And we've seen that when the queue's been short and we've had a very similar looking waiver, we've seen how quick the agency can work if we fall in the right part of the year with the right queue and everything there, and how rapid that progress is when our customers can get something approved, go out and do it, find out what didn't work in that operation, request an amendment and get an amendment approved, all in that kind of the same time they're on site. Would be, fantastic.
And I think, quite frankly, that this is changing. I think the FAA has been aware of this, at least from the discussions I've had with people involved near that office. And I think they're making the process easier with the flying over people recently for that specific reason, to be able to give more bandwidth. I think the Part 108 or whatever it's going to be called in the future also is going to be a change to help relieve, those waivers. If there are so many waivers that are being submitted, there is a reason. It means there is a need for it. Let's find a way to make regulation to not have a waiver needed, and then keep the waivers for those very specific activities, like you mentioned, that are very, very unique. What's the future for Censys? What does it look like in the next 5, maybe 2 to 5 years? What do you think are the next big changes coming up?
So in the super short term, we'll call it 12 to 24 months, it really looks like continuing to expand the software side of our house so that as we're collecting large amounts of data over large parcels of land, over many miles of infrastructure to find certain problems, whether it's a hotspot or invasive weeds or vegetation encroachment, doing something about the back end so that as we create this problem of big data, we can eliminate that problem at the edge. So edge processing on board the aircraft so that intelligence doesn't take a couple of days or weeks to filter through, a BVLOS crew, they go out and they do their thing and they collect a ton of data. And then a month later, you get a report, and I think a real world example for the state of Florida is Hurricane Ian shows up a couple years ago and devastates our beaches with flooding and erosion. And, then our governor allocates money to replace the sand on our beautiful beaches here in Florida. However, the crews didn't know where to put sand for about a year and change. So we can't restore one of our biggest industries, tourism, here in Florida, for over a year because of a lack of intelligence of where to put sand. That just seems like it could be easily solved with a variety of things, but technology being one. And you're talking about a multi-billion-dollar industry just in the state of Florida that could be solved by accurately and quickly and getting information to surveyors and contractors and whatever you might have. So I think that is going to be a really, really imperative thing for us to succeed on, both as Censys and as an industry. I feel like I've said that a lot in this interview series here, but it's important for all of us and especially Censys. And then further on down the road than that, it's going to be certification of the platform. So getting the aircraft certified to fly in the greatest population densities permissible, 10,000 people per square mile or more, so that you can fly Orlando. If a hurricane hits Florida, I'll go back to that same example. If a hurricane hits Florida and State Farm wants to know if this guy's roof was screwed up before or after the hurricane, and he lives in downtown Orlando, I can go fly or hit a button and the drone flies and maps all of Orlando and gives that information to State Farm before and after the storm to eliminate fraudulent insurance claims. That's another example, only permissible through or possible through a certification process of the airframe.
Is that type certificates, Part 21 certification?
That's
Is that what
correct,
you guys
yep.
looking at?
I remember a couple of years ago in California when we had those wildfires that in Paradise they took all these photos for damage assessments and also to be able to share that with the homeowners of that town. That one of the big challenges was getting all those photos, thousands or tens of thousands of photos, off the SD cards and then process them and then turn it around so that people could actually act on it. And that was a big challenge back then. So I can definitely understand that if you can speed up that process, then there's a lot of value to be unlocked there. What I wanted to ask you is you said that Ohio is a very forward-thinking state when it comes to the use of drones. Which other states in the United States are very pro-drone in that sense?
Well, I think we all see a lot of stuff coming out of North Dakota. I think North Dakota is incredibly pro-drone. I think Virginia is incredibly pro-drone. And you see a combination of reasons why that's the case. Of course, it's state leadership. Of course, they're the ones signing the bills, getting the funding and all that other stuff. But you also notice that there's some fairly large private industry present in those regions that are driving a lot of these policy, whether it's changes or funding or direction. You have a lot of private industry calling for certain capability that requires certain policy and certain funding. So, I mean, North Dakota and Virginia are two big ones that we see a lot of. Really anywhere with a test site is a good that's a good first check box. I mean, Alaska, even though those folks are way out there, they've been doing quite a bit of work on the drone enablement front for many years. University of Alaska Fairbanks, and you look at Alaska DOT is one of the more impressive UAS programs from a DOT perspective. Kind of goes back to air and ground risk. They have a unique environment over there that allows them the flexibility to do certain things that maybe Caltrans can't in California and in Los Angeles. there's it all comes down to back to air and ground risk. But yeah, I think Virginia and North Dakota, if I can only pick two, would probably be two of the more kind of pro drone states that I could think of besides Ohio.
Yeah. I guess since we're still kind of early days in the development of the drone industry, the states where you have vast open areas like Alaska, for instance, it's safer and therefore easier to allow drones, I guess, to be used. And there's a lot of benefits for sure there as well to be had. The last question I wanted to ask you, for instance, last weekend, if you just go out and about, you're not working, what is your favorite drone to fly when you're not on the job, so to say?
Good question. I used to do a lot more flying than I do. I know that whenever, this is going to sound like work, but whenever we go out on our big summer road shows, we're doing demos and whatnot, but we're also out in beautiful parts of the United States doing these summer road shows and what have you. And we do a lot of drone on drone filming with, the Mavic series. We have a lot of different products from that we use for marketing and what have you. And we love flying that Mavic around, both for our own marketing purposes, as well as just general consumer type level entertainment, getting some of those shots. And, we fly in these such beautiful areas and the landscape is just incredible. And being able to kind of do both, fly everything from, an Avata, some of the public safety demos we do, they bring out their Avata and it's so fun to fly around with the headset. And kind of zoom around, put it in sport mode and zoom around all the way up to, we have different commercial partnerships with multi-rotor companies that are doing cool stuff in the United States, both interior and exterior aircraft, indoor confined space type stuff. I think, but if I could only pick one, I'd probably pick something along the Mavic line.
Yeah, I hear you. The Mavic is still kind of hard to beat when it comes to an easy to fly drone that basically does it all. Well, thank you so much for your time. It's been a really cool interview, and it's been awesome to learn more about what you do and about what Censys does and the latest in the drone industry from your perspective. So I want to thank you for your time, and for everybody who's been listening or watching, please do like and subscribe to our podcast. It helps us out quite a bit. So yeah, thank you, and we'll be back with another PiXL Drone Show shortly.